Hi friends, welcome back. Now, after looking at the definition of arrays, the various operations performed on the arrays, now it is time to see the different types of arrays. So let's get into what are the types of arrays. So the array in the simplest way can be a one-dimensional array, or it can be any higher dimension. So in general, we can call it n-dimensional. So it can be one-dimensional, two-dimensional, three-dimensional, and so on, depending on the type of the data we are dealing with and the size of the data we are dealing with, and so on. So that's pictorial representation. Just makes the thing simple. So we have a one-dimensional array which represents a, vector in a mathematical sense. A vector can be represented using a one-dimensional array. Same way, when we have a matrix, then we can go into 2D array, and same way we can keep extending to 3D. So this is 1D array. That means there are elements which are oriented in one direction. So he can see one, two, three other elements which are aligned along one row. Whereas when you say 2D array, then it is combination of row vectors and combined together. So we can think of three row vectors, 1 2 3 1 2 3 1 2 3, connected one below one. So that makes rows and columns, and that's how we can represent a matrix. So if we are talking about a 1D array, so we can define them as array 1D array. Same way, when we are defining a 2D array, then we can define this way. So this is a Python version of definition, but similar definitions we can use for any other language like C, C++, Java, and any other thing. Coming to the next version will be a 3D array where we have a stack of matrices, 2D matrices, so stacked one with other. So that makes a 3D. So it gives a cubical illusion. So this is a 3D array, and this 3D array, if we have multiple such 3D arrays, and if we put them in either a row or a column, so multiple cubes, if they put one side other, then we can call that as a 4D array, and that whole thing is repeated, then it becomes 5D array, and so on. So in all, it is, we can say, ND array, where n is a variable. So when you are working with 1D array, then as we have seen in the previous examples, while coding, we made use of a loop, and this loop we had used and to identify the element. So one loop per dimension. So if we are working with 1D array, that's what we were working earlier. So we had used one loop, that is for I equal to 1 to n and all that, so that we can do. But when we are working on 2D array, then we have a loop inside another loop. So outer loop may talk about the row numbers, and the inner loop may talk about the column numbers. So this one we can say that it is first row, first column. This 2 is first row, second column. This 3 is first row, third column. Whereas this one is second row, first column. This is second row, second column. This is second row, third column, and so on. And same thing we can extend to the 3D array, where we have 3 loops, one inside other. So one loop, outermost loop, will talk about the each of these planes. So the red plane or green plane or the blue plane. Then once we are in any particular plane, once we are in any particular plane, then as we each plane will be a 2D array. So we can make use of 2 more loops, one for the row, one for the column, and that way we can take up. So that's all about the different dimensional arrays possible. So more details will follow. Keep watching. Thank you.